Welcome to our maths lesson, and today I want us to introduce what we call rates. You'll notice as we go by this lesson, you'll notice that there is already a talk we always come across which involves rates. Is only that maybe we've never put it mathematically, but generally rates is something that is very common in our daily life situations. And here there is going to be a slight difference when we look at the ratio and when we look at the rates. The ratio which we covered earlier on, we were looking at we were comparing quantities of the same units or similar units. But now here, about the rates, we are going to compare quantities of different units. So with the rates, it is two different units being compared. But when you look at the ratio that we covered, we only considered same type of units. So rates, in most cases, as I have said, it's something we come across in our daily lives. Taking, for example, if I may take, several of us have seen cars. If you are using cars, you have to fuel a car so that you can drive certain number of kilometers in your journey. So the moment you fuel, we can ask ourselves, how much does this vehicle consume per kilometer? The moment you talk like that, you are looking at the consumption in liters and the distance per kilometer. That one is already a situation where we have two units. That is distance in kilometers and capacity as per the liters. So we shall be comparing two units when we look at the issue on the rates. So we have so many situations that we can compare the rates, and we shall look at them as time goes. So what is it that we look at the rates? Rates Rates compare quantities that are measured in different units. Two is that all the rates rates must include units for each other. Also, when we have two different units, they are separated by a symbol or a mathematical symbol like that, which is a mathematical symbol that means per. So when you see this symbol, it is per. A good example of this, you can say, my dad was driving home at 20 kilometers per hour. front slash means per. I also want to say that it is convention to write rates. It is convention to write rates in simplest form. It is convention to write rates in simplest form. So where possible, simplify. And in most cases, it is recommended that you write the second unit as a unit, as one, or you simplify it to be just one unit. That's what we mean by simplest form. If I may take you through why we need to write rates in simplest form, and I'm saying that most probably the second unit must be at least a unit or single one. For example, if you spend $45 in 3 hours, if you spend $45 in 3 hours, then the question would be, what is the rate of expenditure for every single hour? In other words, I'm saying, how much do you spend per hour? So in this situation, this is the second unit, this is the first unit. We need to make the second unit to be 1. That's what we are trying to refer to, so that it's per hour. So we shall be required to divide by 3, so that you have 1 hour, and 45, you divide also by 3, you get it is $15. So therefore, we can conclude and say this expenditure would be reduced to be $15 in 1 hour. $15 in 1 hour. And because it is 1, we can simply now bring in and say it is equivalent to, say, $15 per hour. $15 per hour. There is what we call the average rate. Now, when you look at average, in most cases, this is not new when you talk about average. Mostly, when you talk about average between two quantities, you normally take the sum of the two quantities over 2. What happens when we talk about average rates? Here, the average rate is calculated by dividing the total change in one quantity by the total change in the second quantity. Let us look at this example and then we see what you're trying to say here. Reading a 400-page book in 4 days. Reading a 400-page book in 4 days. So the question that is coming here, we are to find the average reading rate. The average reading rate. And the average reading rate this one will be found as follows. We have, how many page book do we have? It is 400 pages. And it is read in how many days? In 4 days. So here, when we talk about average reading rate, I want you to see, to take you back to our definition that the average rate is calculated by dividing a total change in one quantity by the total change in the second quantity. What is the total change in the second quantity? You see, it is a total of 4. So the total change in the second quantity is 4. That is what we are going to divide for to get the average reading rate. So you'll divide this one by 4 and divide the pages also by 4. And if you do that, then we find that therefore the average reading rate becomes 400 divided by 4, which is 100 pages. And then 4 days divided by 1 is in 1 day. So we are saying here that the average reading rate is 100 pages in 1 day, which can also be written as 100 pages per day. This is the average reading rate. Let us look at questions touching on simplified rates. How do we write simplified rates? Express each of the following as a simplified rate. Express each of the following as a simplified rate. 1, or A, 12 students for 2 teachers, and B, $28 for 4 kilograms. So let us first start looking at the first part, and we want to simplify. We want to simplify 12 students for 2 teachers. In other words, we want to find out how many students will be for 1 teacher. That is what we mean by simplifying. So first we shall take and as I said earlier on, it's like we are looking for the average rate of students per student, per teacher. Therefore, we are going to divide by the second, the change of the second quantity, which is 2. So here, what find how many students per teacher? We shall divide this side by 2 so that we have 1 teacher. Divide 12 by 2. You'll have 6, so we have 6 students for 1 teacher, which can also be written as six students per teacher. That is how to approach this question. So this one is a simplified rate. The second question, we have $28 for 4 kilograms. If $28 is for 4 kilograms, we want to find out here how much it will cost per kilogram. So in this case, first step, we shall have to make the second quantity to be 1, or to be a unit, so we divide by 4, and the first one also divided by 4. When you do that, you'll find it is equivalent to $7 for 1 kilogram. This can be written as $7 per kilogram. And we call this simplified rate. Let us now look at finding simplified rates. Let us now look at the second one. We are done with the simplified rates. Let us look at finding average rates. Looking at this question about finding the average rate, Tom was 120 centimeters tall when he turned 10 years. He was 185 centimeters tall when he turned 20 years old. Find Tom's average rate of growth per year between 10 and 20 years of age. What is his average rate of growth? Now, I'll start by looking at average rate, how it is taken to be. We say that the average rate is taken to be the total change in the first quantity divided by the total change of the second quantity. Total change in the first quantity divided by total change in the second quantity. So let us look at the first quantity here. It is referring to the height, which is changed from 120 to 185 centimeters. The age was between 10 and what? And 20 years. So here we shall first find out the change, because the average change is simply total change the average rate is total change in first quantity over total change in the second quantity. That is what an average rate is. So the change in this case here we are looking for is the growth. How far he grew between 10 years and 20 years. So the growth is we first find the growth, which will be 185 minus 120 centimeters. This gives us 65. It gives us 65 centimeters. So this is the change in growth. When this change was taking place, what was the number of years between? So realize that this change took place between age of 10 and 20. So the change is 10 years. So we can now come up and find out what is our average growth rate. Find Tom's average rate of growth per year. So Tom's average rate is equals to total change, which is 65, divided by total change in years, which is 10 years. This one we are dividing by 10, which is a power of 10 with 1 0. So we shall move a decimal point one step to the left. So we have 6.5 centimeters per year. So the average rate of growth for Tom is 6.5 centimeters per year. That is how it keeps on increasing. So you should have seen what is very necessary when we are talking about average rates. We need to identify the two quantities that exist, what changes took place between the two quantities, what is the total change of the first quantity, what is the total change of the second quantity, and then we divide total change of the first quantity over the total change of the second quantity, and there you'll be done. Now, I want you to look at this table, and we are asked match each rate in the first column, match each rate in the first column with its most likely rate in the second column. Before we look at these several situations, I want you to understand that not all the units are applied anyhowly. Every rate has got its units, unique units. So the moment you go through a statement, there is possible units that we are supposed to go and use. So you don't just take a unit and say this one is going to be maybe dollars per meter and so on. There is simply a guidance from the first part, and then you see. So we want to match. What should give us a clear explanation of employees' wage? Is it 90 people per day? Speed of a car, is it $2,100 per meter square? Cost of building a new home, is it 68 kilometers per hour? Population growth, is it 64 bits per minute? And what if it's about resting heart rates? Is it $15 per hour? Now, here, we shall consider the situation in the first column and try to understand it and see clearly what does it simply mean. When we talk about employees' wage, we are looking at how an employee earns. Employees usually earn in terms of either at the end of the month, which we call salary. It could be maybe after some little time, which we call wage. And it can also be given as per day. Or it can be paid even per hour. What is this that is being paid when an employee works? We pay the amount in dollars. Which means this employee should be working should be paid either certain dollars per month, or certain dollars per week, or certain dollars per hour. Any information related to this one on the right hand side, we shall match the employee's wage. Which one is it? So you should have realized that the only one which is telling us maybe dollars per time is $15 per hour. So you can say that employee's wage, you see that arrow, is rated at $15 per hour, right? Then, speed of a car. So we are done with this. The speed of a car, is it given as 90 people per day? Is it given as $2,100 per square meters? Is it given as 68 kilometers per hour? Is it given as 64 bits in a minute? This one has already been taken care of. The speed is usually measured either in meters, or in kilometers, or in miles, and so, or in nautical miles, depending on what you are dealing with. For this one here, that speed that is what we are referring to should be either in form of, when you're talking about how many kilometers in how many hours. So we are referring to something per hour. So when you look at speed, you'll match this speed of a car with 68 kilometers per hour. Cost of building a new home. How do you construct a new home? Is it 90 people per day? Definitely not. Is it 64 bits per minute? No. We construct a home by measuring the surface area of where the material will occupy. That simply means we shall look at how much are we spending in certain square centimeters or square meters. So, cost of building a home will be matched with $2,100 per square meter. That's what you shall say. The last one, you don't need again to start thinking loud and looking for it. We have got two more remaining, sorry. The second last is population growth. And the last one is resting heart rates. Population growth is about people. Anything touching on people here is the first one. People. So the population growth rate is 90 people per day. 90 people in a day. When you talk of 90 people in a day, it means averagely, when you wake up in the morning, by the end of 24 hours, 90 people have been born. That is what this rate is trying to tell us. That is the population growth rate in a particular country. And the last one, which is resting heart rates. Heart rates is measured by heartbeats. And the only heartbeat we have here is here, 64 beats per minute. Therefore, resting heart rate will be measured by 64 heartbeats per minute. That is what we mean by looking at the situation and the kind of rate that will apply with that situation. Now, let us look at this question. A car uses 24 liters of petrol to travel 216 kilometers. Express these quantities as a simplified rate. In one part is kilometers per liter, and the second part is asking us in liters per kilometer. That is, how many kilometers can this car travel per liter? And this is asking us, how many liters are consumed per 1 kilometer? That's what simply this one is trying to tell us. And two, how can you convert kilometers per liter into liters per kilometer? So first, we start with the first one. We are talking of the first unit is kilometers. So I'll interchange these and start with 216 kilometers in, for how many liters? For 24 liters. When you look at the second part here, it is asking us to find how many liters are consumed per kilometer. So here we are looking at our rate. How many liters are used? So we are talking about how many liters here? 24 liters in 216 kilometers. 24 liters for 216 kilometers. So we are interested per kilometer. Therefore, we divide the second quantity by 216. Same, we shall divide the first quantity by 216. So the second part, we shall find 216 divided by 216 is 1 kilometer. But 24 divided by 216 So when you take 24 divided by 216, you will get 0.1. I've put a bar here, or you can use a dot because 1 is recurring. So it's 0.1 liters for 1 kilometer. Therefore, our simplified ratio is 0.1 liters per kilometer. 0.1 liters per kilometer. That is what we get. So what do we mean here? You find that we have looked at this and found the number of liters consumed in every kilometer. But now we are being asked to find how do we convert kilometers per liter into liters per kilometer. Take note of the following. The second quantity must always be reduced to 1. So when you are given kilometer per liter, our interest is to make the second quantity to be strictly a 1. And that's why what we did here, we first introduced and said that we had 216 kilometers for how many liters? For 24 liters. But the moment they were asking us for liters per kilometer, then the first quantity is no longer kilometers, but it is liters. So we shall talk of 24 liters for 216 kilometers. So we can simply work out on this conversion by referring to how we make one of the units to be a 1. Now, taking for example what we have, like in the first one where we had 9 kilometers per liter. And then the question goes ahead, but we want to have liters per kilometer. Again, this one would still help us. We would still pick up from here and say this statement, this rate means that it is 9 kilometers for 1 liter, which is also, if we interchange, it means 1 liter goes for how many kilometers? 9 kilometers. Then our rate that we want to find now, liters per kilometer, we would divide this side by 9 to get a kilometer, and then divide this side by 9, you get 1/9 liters. Which again, when you go further and divide, you will find that it is either 1/9 liters per kilometer or 0.1 recurring liters per kilometer. So you can simply pick up the conversion from any point, either from the original approach, or you simply look at the rate that we had, the first rate that you had, and use it to find an alternative rate. If 30 salad rolls were bought to feed 20 people at a picnic, and the total cost was $120, find the following rates. 1, salad rolls per person. 2, cost per person. And 3, cost per roll. So we have got this question being broken into about 3 areas. So we shall start with salad rolls per person. Question is, how many rolls were bought for all these people? We are talking about We are talking about 30 salad rolls for 20 people. But the question is asking salad rolls per person. All right. So for us to work this, we shall be required to change the second unit quantity to 1. So we shall divide here by 20 so that we have 1 person. So how many salad rolls per person? This one will be 30 divided by 20, which can be in improper fraction. It is 3/2 salad rolls for 1 person, or simply 1.5 for 1 person, which can be written as what? $1.5 salad rolls per person. 1.5 salad rolls per person. So first part is answered. How many rolls per person? It is 1.5 or 1.5 or 3/2 salad rolls per person. The same question goes ahead to ask us cost per person. So I want us to look at this. How much has been spent on all the 30 rolls? All the 30 rolls, our total expenditure is $120. So because we want cost per person, what is our first quantity? From here, it is cost. And the cost is what? $120 was spent on how many people? $120 was spent on 20 people. How much was spent per 1 person? So you'll divide again this by 20 to find 1 person. Divide this other side by 20 to get the cost per person, which you get, it is a total of $6 on 1 individual. So we can conclude and say the rate is $6 per person. $6 per person. Lastly, cost per roll. Again, I'll ask, what is the first quantity that has been used? It is cost. And the second quantity is what? Roll. So, how much was spent on all the rolls? There were 30 rolls and a total of 120 cost. So we are talking of $120 for 30 rolls. So because we want to find per roll, we shall divide by 30. $120 divided by 30, you'll get it is 4. For 1 roll. Therefore, we can conclude and say the expenditure is $4 per roll. $4 per roll. A dripping tap filled a 9-liter bucket in 3 hours. What was the dripping rate of the tap in liters per hour, and 2, how long would it take the tap to fill a 2.1 liter bucket? So let us start with the first part. We are talking about a bucket here that is 9 liters, and a tap drips for 3 hours to fill it. So the question is asking liters per hour. So we are asking, it takes 3 hours to fill a 9 liter bucket. So 9 liters for 3 hours. So how many liters per hour? This is very straight. Our rate will be divide this side by 3 to get 1 hour. Divide this side by 3 to get 3 liters for 1 hour. So it means that it actually, for 3 liters, it is simply the rate at which this tap is dripping is at the rate of 3 liters per hour. So we write it (3 liters per hour). You can write HR, or you just write H. So 3 liters per hour. Then we are asked the same in the second part. Supposing we change the bucket. Now it's no longer a 9 liter bucket, but it's a 2.1 liter bucket. Before we even tackle the question, I want to ask you, do you think the tap will take long or it will take short? Do you think the tap will be faster or slow? Using common sense, 9 liter bucket is large in capacity compared to 2.1 liter bucket. Given that the rate is not going to change, then we expect this tap to fill a 2.1 liter bucket much faster than the 9 liter bucket. All right? So let us now look at that, and we shall look at it by looking at using the rate that we have, because this is already the rate per hour. They are not asking us for the rate here. They are only asking us how long it will take. How long it will take. The answer of the second quantity is open. It is not per hour. So we are saying this. 3 liters for 1 hour. How long will it take to fill 2.1 liters? That is what one of the approaches, not all, but just one of the approaches. So the expected time, I would wish that we improve on this, because we expect it to take less, because this is already 3 liters and this is 2.1. We can still convert 1 hour into minutes so that we have 60 what? 60 minutes here if we don't want to use 1 hour. But first, let us start with this and see what will happen. So definitely we expect the time here to be less. So one of the approach that is taken is this. The time taken here will be 2.1 liters multiplied by 1 hour divided by 3 liters. Now, this is liters L and this is liters L. It simplifies to remain with hours. 2.1 multiplied by 1 hour is 2.1 H over 3. This is a numerator with a decimal and a denominator as a whole number. We have learned on how we can simply simplify this. So we can either use a calculator or we simply remove the numerators, the decimal, and simplify. So multiply, because it's one decimal, multiply by 10 here, multiply this one by 10, so that you have 21 over 30. Remember, it is hours. By 3 here is 10. Okay? By 3 here is 7. So we are having 7 over 10 hours. Now, it might look odd, but we know 7 over 10 is less than an hour. Can we make it to be in minutes and see? If we have to do that, then we are saying 7 over 10 of 1 hour. So I want to convert this. This is an answer. It's allowed. It's an answer to this. But supposing we are asked to find it in minutes, we will be talking of 1 hour is equal to 60 minutes. So convert 1 hour to 60 minutes. So we are looking at 7 over 10 of 60 minutes. Of can be changed to be a multiplication sign. So we have 7 over 10 times 60. By 10 is 1, by 10 is 6. So this one becomes 42 minutes. That is 7 multiplied by 6, 42 minutes. There is a second approach we can give here. This is one of the approaches. How would we approach the same question here using the second method? Second method now, I want us to make sure that we are talking here as the unit as a liter. So how long does it take this tap to fill a capacity of equivalent to 1 liter? Let us start by that, and then when we talk about 2.1 liters, we only need to multiply. So let's see. Second approach of part 2. We've been told here that this tap, we can start from the first part. This tap actually takes 3 hours to fill a 9-liter bucket. So we want to make a liter to be 1. So I'll say 3 hours for 9 liter. How about, what would be the rate of time per liter? This one will divide, we are looking at rate of time per liter. We divide by 9 here, we divide by 9 here. And you'll find that for this tap to give us an equivalent of 1 liter, it will be 3 divided by 9, which is 1 over 3 hours for 1 liter. 1 over 3 hours is equivalent to how many minutes? You'll find that it is equivalent to a third of 60, which is times 60. By 3 is 1, by 3 is 20. Therefore, it is saying 20 minutes for 1 liter. Then our question comes. 20 minutes for 1 liter. How about 2.1 liters? So for 2.1 liters, it will mean we shall multiply here on this side by 2.1 and this other side also by 2.1. Let us see. That is the rate that we have. 20 minutes for 1 liter. What happened? For us, we are going to multiply here by 2.1 liters so that we have 2.1 liters will be going to have 20 minutes multiplied by 2.1. When you do this, you will get 20 times 2.1. The whole of this, it is in minutes. Now, this is a multiple of 10. When you are multiplying with a multiple of 10, the decimal place moves one step to the right. So this is the same as 2 times 21, which gives us 42 minutes for 2.1 liters. So the second method is still giving us similar answer. So you can use it. This is a unitary approach where you simply use 1 unit to get the rest that you require. For the first one, we are just looking at the rate irrespective of which one came first, but the main idea was to find how much time will be taken for us, for the tap to fill an equivalent of 2.1 liters, and you have found it's 42 minutes. So today in this class, we have learned about rates. And we have said when we are talking about rates, the second quantity must be equivalent of 1. That is what a rate simply means. And if you have to change the rate, for example, if you have been given kilometers per hour, this one is trying to tell us the number of kilometers covered per 1 hour. Sometimes you can be asked, how about if we want to find how many hours, the time consumed for 1 kilometer? Then it will mean that this one you don't just interchange, but you will refer to the question that you have and you go back and find out. Whereby now you'll be talking of the time taken for the kilometers. And here you'll always now be required to reduce the side of the kilometers or the distance to 1 particular kilometer, and then the time will just come automatically. So in general, when you talk about rates, as I told you, it's a matter of comparing two quantities. A point to note, the quantity units must be specified at every given time. If you are talking about people per year, let us have people as our unit and the time given there. If we are talking about liters per hour, we must have liters given and also hours given. So the units, when we are talking about rates, both the two different units must be indicated. So that is it for today. When we meet in our next class, we are going to continue with the rates. And this time, we shall be looking at the rates and ratio together in unitary method. Thank you.